Welcome everyone. My name is Dr. Michael Pittman of the Department of Earth Sciences, and today I will be facilitating this session, which is all about studying geology and Earth system science at HKU. So I'm very pleased to be joined here by Dr. Jess King, who will be talking about majors in geology and geology intensive. And we are also joined by Dr. Yi-Lang Lee, who will be talking about the major in Earth system science. So welcome, Dr. King and Dr. Lee. Just a brief breakdown of how this session will work. First of all, Dr. King will talk about the geology majors, and then there'll be a short time for questions. Then we'll move on to Dr. Lee talking about the Earth System Science major, and then we'll have extended questions afterwards. If you would like to ask a question, please type your question in the chat box, or if you prefer to talk and just say your question, then just put your name in the chat box so that I know how to introduce your question. Great, so without further ado, I'd like to hand the floor to Dr. King. Dr.
Hi everyone, welcome to this presentation. Thank you all for coming, and I'm very excited to be able to talk to you because I believe that you must be interested in doing earth sciences. As Mike said, I am Dr. King. Most people call me Jess, and I am a geologist, amongst other things. And one of the questions I get most asked when I'm doing these presentations are, what is the difference between geography and geology, and the difference between geology and earth system science, and earth system science and environmental science? And I think that's what we would like to address or help you discover today. So as I mentioned, I am the geology major coordinator, and so today I'm just going to take you through a little bit about our geology majors. First off, though, I'm going to welcome you to the Department of Earth Science. We are established in 1995, and since 1996, we've been graduating students with geology and earth science degrees. The department is has truly international and world-class academic staff, including several members of the National Council of Science. And our teaching aim is to produce professional and skilled and happy and highly competent earth scientists, compliant with requirements for professional chartership programs. And in the case of HKU, this is the Geological Society of London, for the scientific community, the professional sector in Hong Kong, and also for the benefit of society. We offer two major discipline areas, geology and geology intensive, and as I mentioned also, earth systems science. And we are the Department of Earth Sciences. And what is earth science? We deal with the scientific issues to do with Earth and all its spheres. So that could be the geosphere, so the rock sphere, hydrosphere, talking about the oceans and the water systems, atmosphere, of course, the air, biosphere also included, etc. And what I would like to talk to you about today is the geosphere and the study of geology. Now, as I've mentioned, most people ask, how is geology different from geography? I think most of you have studied geography at school. In geography, we tend to look at things to do with human society and interactions of the human society with the Earth's surface. For earth science, we kind of take away the human issue and we're left with physical geography, or what we like to call cool geography. And in geology specifically, we kind of dedicate ourselves to the solid Earth. We study the rock cycle and in the environments of deposition and creation of these crustal rocks. We look at how they're formed, how they relate to each other, how they break down, and how a change in one system affects all of the other systems. And this includes the Earth systems, which, well, Ilang will talk to you shortly on, but this is more of the superficial processes. We also look at the past, present, and future behavior of the solid Earth systems. This is to enable us to investigate potential geological and natural resources. It may be to do with looking at geological hazards, but by studying the present state of the Earth's surface and the solid Earth, we can investigate the past and look forward into the future. And the way we do that is basically by starting off with what we see on the Earth's surface right now. I'm going to start this. Is it going to? There we go. Okay. Yeah, it's loading. Excellent. So we take a look at what we have now. So the Earth's current configuration. We look at the seashore, we look at the rocks on the surface, we might look at the vegetation around, and we try and look at the processes that are forming the rocks. So that might be things like, well, super exciting, things like volcanoes or erupting igneous rock types, magma and dust clouds and pyroclastic flows and all these fabulous things, and making igneous bodies that form on the surface of the Earth. But also we try and study the geochemistry of that and look at what the magma was like deep in the Earth's crust. We might also be looking at rocks on the surface of the planet that are caused by collisions and great pressures and great temperatures baking all of the different rocks to change their nature. These are the metamorphic rocks. So we study where they occur on the Earth and see how we can relate, how we form them. We also look at the way these rocks interact with the atmosphere, the way they might be chemically or mechanically broken down, and how those particles of the broken down rock are transported from one place to the other, maybe by air, maybe by rivers, and how those materials are taken to low points on the Earth's surface, sedimentary basins, and create sedimentary rocks. By doing this, we are studying how the rocks form, understanding how the rocks form, and we get to know their environments. So by looking at rocks that have been deposited maybe 200 years ago, we can say, okay, we know that that rock was made in this environment, and we know that that environment existed 200 years ago. So we can piece together all of the different rocks occurring all over the Earth at different times and recreate the Earth's history. So a great tenet of geology is the present is the key to the past. Oh, yeah. Not only do we look at the Earth's crust, by observing things like earthquakes and volcanoes, we can also use that information to reconstruct what the interior of the Earth is. So we look at this crustal area, we look at the rock types that are there, and we can reconstruct what is in the mantle. And by looking at things like earthquakes, they create seismic shocks that actually allow us to read what is even deeper in the Earth's interior, so we can find out what makes the core. Now, this is super exciting because this relates to the mechanics that drive the creation of the crust itself, but also these create the dynamic things like the Earth's magnetic field. So we are able to not just look at the solid Earth, but also the near space environment as well. And not just of the Earth, but also of different planets. We can use the same techniques. So really what we're looking at is how the Earth's crust is formed. So we can identify natural resources that we use, things like metals, like special elements that go into making your batteries for your mobile phones, things like petroleum and fossil fuels that we have previously used for our energy sources. Who knows what will happen in the future? Maybe we go to oceanographic sources, so renewable energies such as water, waves, wave energy, solar energy, geothermal energy from active earthquake zones and volcanic zones. But also, we're looking at things like earthquakes themselves, volcanic eruptions, climate change, these natural hazards. So, by and large, we're doing an awful lot of exciting things looking at the solid Earth. And because we're looking for natural resources, energy sources, and also natural hazards, geologists and earth scientists are in good demand globally. It's a good thing to study if you want a nice job at the end, and a fun job, it has to be said. So since 1996, the Department of Earth Sciences have had over 500 graduates. And in Hong Kong, we tend to, our graduates have a very successful placement in terms of getting jobs and in future careers. And usually we tend to have our graduates go into the engineering and geotechnical field, helping sustain the development of Hong Kong and also the South China area. Surveying companies looking for natural resources, mining companies, but also going into government and consultancy, going into education and school programs. So many of your teachers might have been geology graduates, but also research management and planning, disaster management, and environmental testing. And now a new area that's opening up is geotourism. So we have UNESCO World geoparks here in Hong Kong, and they're proving very popular and a beautiful landscape. So those are also potential places of employment. So in terms of our geology major, as I mentioned at the start of the presentation, our aim in teaching geology is to train our graduates in solid earth geology and related disciplines to prepare you for careers as professional geologists pursuing maybe geotechnical investigations and mining and resource development, etc. But also to train you as a very good scientist for the scientific community. And this, of course, benefits society at large. Our degree program is compliant and with geology programs internationally. We have a very classic geology core disciplinary study. We do field geology, mineralogy, geochemistry, petrology, geophysics, structural geology. And this, of course, includes a lot of fieldwork and independent fieldwork. So writing technical reports, but also working as a team. And this is common as an international standard for all geology degrees. Our elective courses also prepare you directly for work placement in Hong Kong, but also in international industry as an international standard. So we tend to have electives in engineering geology, hydrogeology, rock and soil mechanics, and other very applied and specialized areas. We are training you to be professionals, of course. We also have a new intensive version, which is aligned with Geoscience Accredited Pathway for the Geological Society of London. And what that means is that this accredited pathway is a much more intensive version of a standard geology major, but designed to give you a very comprehensive fundamental basement in all geoscience study. What this gives you is the accredited pathway, which is a fast track to being a professionally registered chartered geologist. So that means you will be at the top of your profession in a far faster time. And it is in fact the choice degree for some of our industry partners, such as the CEDD, the Civil Engineering and Development Department in the Hong Kong government, and the Geotechnical Office, as well as a fast track to become a member of the Hong Kong Institute for Engineers. So it's a really worthwhile degree program to go for. It's also internationally recognized as a very comprehensive training in the earth sciences. Now, how we do that is you have two pathways. You have a standard geology major, which is 96 Faculty of Science credits. This means you have credits left above and beyond to be able to do another major of your choice in another area of science, or even any other area in the university. But it will still give you a very good classic training in geology and earth science. So in there, the core disciplinary credits you will need to do are 66 plus your electives. If you wish to go into geotechnical engineering, we have a load of electives to focus you on that. But if you wish to go into mining, you might choose earth resources. If you want to go into paleontology, for example, like Dr. Pittman, you could choose Earth Through Time, and we've got some more courses coming online for that as well. So there's a lot of option for you to go into an area of specialization of your choice. For the intensive, you have a very much broader and but more credit hungry core, where you are doing 102 disciplinary credits. So that eats away a bit more at your credits. So usually your intensive majors, you will do one major and maybe a minor as a sideline. But students have also been able to do the geology intensive and earth system majors together. So it can be done for those that really want to embrace the earth sciences. One common thing in between them, as well as the disciplinary courses, is we have the opportunity to do internships. And of course, we have the capstone course is our integrated field studies. So a very attractive thing with our major program, the straightforward geology major can be done in 3 years. If you get an early start in the first year with principles of geology, you can do that, complete that major within 3 years, giving you lots of opportunity to do other science courses or more geology courses if you prefer. We also have the common thing, we do a lot of field work. So during the field studies, we have a lot of opportunity for you to visit not just field sites in Hong Kong, but hopefully if we settle down with the coronavirus situation, opportunities to study to local or other regional destinations, Japan, also to mainland China, also going to Taiwan, and also studying in North America. Usually we go to Montana to do our final capstone, which is a 3 to 4 week intensive course in the field. So lots of opportunity to travel and see the world and see beautiful geological formations. So we start off with local field camps, go further out into our local region, and then end up going to very, very distant parts of the world. The other thing we have in common for both is the opportunity of internship. So we have a long and fruitful partnership with the government going into the GEO and the CEDD. So that's the Geographic Information Office, Geological Survey, and the Civil Engineering Department, also the Housing Department, and also Hong Kong Observatory for placing you to do projects in your internship. Also, the geotechnical companies, Gammon and Arup are very good partners of ours, and various other companies offer internships. And the good thing is many of our graduates also end up working with these companies once they've completed their degree program. So you get a feeling of what it's like to work there and potentially even get a job at the end. So here, I'll leave you with a few examples of our partnerships and the employers of Hong Kong U students, as I've mentioned quite a lot in the commercial earth science sector, but also because we might be looking at environmental issues, resource management. We also have quite a lot of students go into the commercial sector, notably in banks and the finance sector as consultants. And quite a few people have also gone into the tourism sector as well. So we've got a very good placement of students. But fundamentally, we really enjoy being geoscientists. And when we go and do our field trips, we're kind of away on a working holiday. And this allows you to bond very well with your other classmates, and many of our graduates develop lifelong friends and a good social network, but also professional network during their undergrad program. And we feel that this kind of benefits you not just from your academic viewpoint, but it's a nice family that you come into. And that's where I want to leave it. And if you've got any questions, please feel free to bring them up now, or contact us in the department, or feel free to contact myself or Mike or Yilang. And yeah, I look forward to hearing from you. Thank you.
Excellent. Thanks very much, Jess. Having looked at it, it reignited all those great memories of being a student in studying geology. So you can see in this particular slide in the top right, you know, how happy it is being in the field. You know, obviously that's like a star part of doing such a degree. So I just wanted to maybe just touch on a few things to add to Jess's great talk. And the first one is to do with, you know, our importance in Hong Kong. So geology plays like a really integral part to the development of Hong Kong. So we have lots of graduates who are involved in, you know, major construction projects, including things like tunnels and land reclamation. So it really kind of tied into how the city works. So, you know, our graduates really play a really important role in the city. The other thing I like to just add to is Jess's point that, you know, fundamentally we're training good scientists, and having someone with a science degree who can think critically, can reflect on what they're doing in different situations, that's a highly sought after skill set. And as you saw with Jess's examples of people working outside of earth sciences, there's a whole range of different opportunities. So it's a really great degree to pursue. So I'm just looking at the chat here. So I wanted to mention, Jess, maybe something just to share your own kind of maybe road to Earth. What got you into geology? You know, what for you was the thing that, you know, really sparked your interest?
Being outside. Being just I at an early age just loved being outside. I was fascinated by rocks being different colors, the landscape being the shape it was, why the seas were there, what made things work in terms of the natural environment. I didn't quite get into the fossils, sorry, but I did landscapes for me, the control of the rock and the landscape, and then understanding how planets are formed. And
Mhm.
that's what kind of got me out there. But
Absolutely. Yeah.
yeah, but since then I've become really fascinated with chemistry.
Hmm.
It got really exciting thinking about how the rocks are made from a chemical point of view, and yeah, and reading the chemistry and reading the origins of the rocks from the chemistry. So a bit nerdy, but it started with liking being outdoors.
Yeah, absolutely. I think that's a very common story for most people that are geologists, being outdoors, finding out about, the world that you're seeing around you. And I think you touched on one before with the Hong Kong UNESCO Geopark, has really ignited a lot of local interest. And I'm seeing, more and more young people really enjoying that and appreciating that outdoor side. So that's really great. And I think, you mentioning chemistry, I think is important because in our subject, we're one of the few types of sciences where we truly touch upon all the different pure sciences. So mathematics, and you mentioned chemistry, biology,
Physics.
physics, we use all of it. And I think it really is for lovers of science in total. If you like whatever area, we've got something for you. So that's really great. So thanks very much, Jess, Dr. King. Jess, as she mentioned at the start of her talk, is the major coordinator in geology and geology intensive. So if you have very specific questions about the major, please feel free to reach out to her, and obviously through things like our Facebook page and also just our generic email.